Okay, now we will do another problem in vector space. The set R cube with vector addition uh, addition operation, this one, defined by this one equal okay. This addition is given by a1 plus b1 plus 5, a2 plus b2 minus 7, a3 plus b3 plus 1. Similarly, for a scalar multiplication is defined by and scalar multiplication defined by CA1 5 times C minus 1, CA2 minus 7 times C minus 1, CA3 plus C minus 1. Okay, let's coordinate this one, comma this one, comma this one. CA1 plus 5 C minus 1, CA2 minus 7 bracket C minus 1, CA3 plus C minus 1. Okay, scalar multiplication is defined by like this, and vector addition defined by this. Your question is so that okay, your question is so that R cube is a vector space R cube is a vector space over real number under this two operation. Under these two operations. Under these two operations means vector addition and scalar multiplication. Your question is the set R cube with vector addition operation is defined by like this. R cube in the triples A1, A2, A3. B1, B2, B3 is addition operation for the vectors. This is one of the vector. It is another vector. The addition is defined by like this. And also scalar multiplication is defined by like this. Your question is you want to show that it's R cube, right? This R cube is a vector space over real number under these two operations. So you want to check there are 10 axioms. If 10 axioms are satisfying, then we can say that it is the vector space. Okay. So first axiom. Now we will discuss the first axiom. First axiom is the closure property of that addition. Okay, closure property of that addition. So that here, let you take two elements, no? Let you take two vectors. Let u equal a1, a2, a3, b equal b1, b2, b3 in V. Sorry, in R cube. In R cube. Is it okay? So right? Then you can take the addition, right? So addition is, okay, that addition is, okay, that addition is vector addition, no? Right. It is U plus V. This one is A1, A2, A3. Okay, A1, A2, A3 plus V1, V2, V3. Okay, A1, A2, A3 and V1, V2, A3. So this one is A1 plus B1, A1 plus B1 plus 5. A2 plus B2 minus 7 is a defined one, right? A3 plus B3 plus 1 is defined one. You know, A1, B1s are real numbers. A1, B1, C1 and A2, B2, B3, right? A1, A2, A3, B1, B2, B3 are real numbers. Therefore, this one also real number, this one also real number, this one also real number. Therefore, this triples in R cube. This means this R cube is closed. R cube is closed under addition. Right? Closed under addition. Next one is commutative, right? For addition. Let to take two vectors. Let use one of the vector A1, A2, A3. B is another vector B1, B2, B3 in R cube. Okay. Your claim is you want to show that this one. It is a commutative for a vector addition. Then you take the LHS side, you take vector addition of U plus B is, what is the formula? A1, A2, A3 is vector addition, B1, B2, B3. So this addition is like this, A1 plus B1 plus 5, A2, B2 minus 7, A3, B3 plus 1. A1 plus B1, we can write B1 plus A1 because I already told you. Because A1, B1s are real number. In the real number, it is commutative satisfying. Therefore, we will write this one is B1 plus A1 plus 5. It is B2 plus A2 minus 7. It is B3 plus A3 plus 1. So, this one, for this one, we will write B1, B2, B3, vector addition, A1, A2, A3. Once you adding these two vectors, you will get this one. Okay? Therefore, what is this? It is vector addition U. Thus addition is commutative. Okay, thus addition is commutative. Okay. Next one, we want to check the associative for addition. Okay, for that, next one you want to check the associative for addition. Okay, for that you want to take three vectors. Okay, u, v, w. You want to take the three vectors u, v, w. Okay, that what, let a1, a2, a3, b is b1, b2, b3. Next one, you want to take the three vectors, no? Then w. W is c1, c2, c3. All are in R cube. Okay, in R cube. All vectors are in R cube. Is it okay? Right. Your claim is this one. Your claim is this one. So you take the LHS side first. Then you want so that that's equal to RHS side. U vector addition, V vector addition, double H. U okay, A1, A2, A3. Okay, A1, A2, A3. And B and W, vector addition. B and W you will write B1, B2, B3, vector addition, C1, C2, C3. Okay, C1, C2, C3. Next, for this part, yeah, it is to take more space, no? Then I will write here. Don't write this equation here. Okay, this equation is here. Okay, right. So this one is A1, A2, A3. Right. This is a vector addition. B1, what is the vector addition for these two vectors? B1 plus C1. Here is define one here. You can use this one. For two vector addition is this one, plus 5. Next one, B2, C2, minus 7. B3, C3, plus 1. B3, C3, plus 1. B3, C3, plus 1. Okay, right. Now, again, addition. This one is A1, B1, C1. Then I think we get here 10. Is it okay? We get here 10. A2, B2, C2, minus, I think it's 14 here. A3, B3, C3, plus 2. Okay. we do some arrangement, okay? Or otherwise, we can do arrangement like this. Is a real number? No, then you take three is one with the element, another element is one element, then we will take the associative there. From this one can be write like this. Here one you get now you take this one element, then this another two element, then you can write this one is 5 plus E1. Another 5 also there. Another 7 also there. Another C2 minus 7 also there. I think here is 2, then 1. So here is 2 there. A3 plus B3 plus E3 plus 1 plus 1. Then, so this is A3 plus B3 plus 1 to take. Again 1 is there remaining. This one we will write A1, A2, A3, with vector addition. Is it okay? Some arrangement we did, okay? Oh, so this is your so this is so what is this? It's U. What is this? It is your V. What is this? It is your W. So this addition is associative. Addition is associative. Okay. Next, you want to find the identity. Okay. Next, we want to find the identity. For an identity, you take this, let U is A1, A2, A3. So its identity is B, value is -5 plus 7 minus 1. This one also both are in R cube. You know, it is identity. Suppose you do the vector addition for this both, then you get again this U, no? Suppose it is identity, you do the vector addition, then you again get this value. Right, that this one, U, V, okay, it's A1, A2, A3, vector addition is -5 plus 7 is -1. Then you get A1 -5 plus 5. A2 is defined one, addition is defined here. This one addition is, no? A2 plus 7 is -7. A3 minus 1 plus 1. Then you get again U, no? A1, A2, A3, because that's a cancel. It is your U. Thus, that is identity. Thus, -5, 7, -1 is an additive identity. Is an additive identity. So, in my question is how we can find the identity here. For that, right? For that, you can denote by this one. It's not axiom. You want to find that B value. So U is A1, A2. You can roughly work it out and you can put that values. Okay, A1, A2, A3. So B you put B1, B2, B3. Your claim is now you want to find, because this U plus B, this vector addition, this one equal A1, A2, A3, B1, B2, B3. So axiom saying that suppose you add this one, you get U. That means here A1, A2, A3. Now your claim is you want to tell what is the B1, B2, B3 values in terms of A1, A2, A3 values. Okay. What is your question? Now you want to tell what is the B1, B2, B3 values in terms of A1, A2, A3. Okay. So that it is a vector addition for this one, A1 plus B1, A1 plus B1 plus 5, A2 plus B2 minus 7, A3 plus B3 plus 1 equal A1, A2, A3. Then coordinate wise, these both are equal. Then this first one is A1 plus B1 plus 5 equal A1. So A1 is cancelled, then we get B1 equal to -5. Is it okay? -5. A2 plus B2 minus 7 equal A2. From this one, A2 is cancelled, we will get B2 is +7. Okay. And A3 plus B3 plus 1 equal A3. A3 will be cancelled, then we'll get B3 equal to -1. Therefore, it is your identity, right? Additive identity -5 plus 7 -1. Which one? This one you can write that values and you will get this. You can check the axiom and you get the additive identity. Okay, roughly you can work it out. Okay. Next, you want to find the inverse. Okay. Axiom number 5, you want to find the inverse. Okay. For that, axiom number 4, sorry, axiom number 5. You want to find the inverse. Okay. Okay, now suppose your vector u is a1, a2, a3 belong to R cube. V, what is the V inverse? Inverse of the form like this. Minus a2, minus a3, minus 2. I think is it not clear, right? What is the V values? Minus a1, minus 10, minus a2, minus a3, minus 2. This can also belong to R cube. So, suppose it is the identity, suppose it is the inverse, then if you do the vector addition, you will get the inverse. Inverse already found in the fourth axioms. Okay, that means a1, a2, a3, it is your inverse minus a1 minus 10, minus a2 minus a3 minus 2. If it is inverse, if you add this 2, vector addition, you get in identity. Is it okay? Wait, a1 minus 10 plus add plus 5. a2 minus a2 plus add plus 7. a3 minus 2 add plus 1. Then we will get the identity because this will cancel minus 5, 7, minus 1, minus 2 plus 1, minus 1. Therefore, it is your identity. Therefore, B is your inverse, right? How get this B values? Here also the questions there, like a previous axiom. So that how we can, roughly you can work it out. Okay, you can separately work it out, then you can write that B values, no problem. U is A1, A2, A3. B is, you will take B1